So today, like other chapters or other module, when we reach to the end of that module, we generally means rather I generally film a video on problem solving. So, and I believe that until unless you solve a problem, you won't be able to learn or gather insight on that particular topic. So here today I'm going to discuss this fundamental of rotating machine problem from fundamental of rotating machine. A few problems I have collected from old books, so it is difficult for me to take a snap and share it here, because if I share those snaps, they will be means uh, barely legible. So it is better that let me copy the problem first and then I will solve. So here it goes. The first problem, three phase. I'm just writing the important data. Single 16 pole synchronous machine has a star connected winding with 144 slots, and 10 conductors per slot. The flux per pole 0.04 Weber, and this one is sinusoidally distributed. And speed is we have to find out the frequency phase and line voltages. Now here if any nothing is mentioned, then you have to consider that total turns So here what you will get if you do that, that we can write first f is equal to what, frequency is equal to ns into p, here ns in rpm by 120. So what is ns? Ns is 375, number of pole is 16, probably we will be getting 50 hertz. Now the next part, we have to find out the total number of conductors. So total number of conductors will be how much? There are 144 slot and 10 conductors per slot, right? 144 slot and 10 conductors per slot. So total conductor this is the total number of slots. So what would be the total number of turns? Number of turns just a minute. Where it is? Hello. It's recording. Now, number of turn per phase, that is how much? Now, what is slot angle in electrical degree? You can find it by doing 180 degree into slot by, sorry. This is 180 degree into pole by slot. So 180, because one pair of pole will always give you electrically 60 degree. And what is the total number of slot? That is 1440. Sorry, 144. So we will get slot angle is 20 degree, right? So slot per pole per phase, will be how much? 144 divided by 16 into 3, that is 3. Now, what is our breadth factor? That is 3 into sine 20 degree by 2. So if you solve this one, you will get 0.96. So what about phase EMF? F phi. Now here, when we are talking about phi, that obviously it is only KB1 we have considered, like fundamental. So we must know that what is its like number of turns per phase we have got, but this flux, which value of flux we will be taking? Like this 240, that flux value, where it is 0.04. The flux per pole is 0.04. So what is this flux? 0.04 flux per pole. Is it the average value? Is it the maximum value? Is it the RMS value of the flux? What type of flux we are talking about? That you must know. And you will be getting your answer soon. Fortunately, this problem exactly fits this formula. So without much thinking or without giving much of your effort, you can easily find out the answer, like 4.44 into 50 into 0.04 into this one, that is 0.96. Since KP1 nothing is mentioned, we have to consider this is a full pitch coil, into 240, and that leads an answer like 2406 volt, and since it is star connected, you can figure out that line EMF will be root 3 times of phase. Fundamental phase EMF, you will be getting 3543.6 volt, right? So this is the case. Now let me pick up one more problem from that book, and gradually it will give you some more idea on our KPR. Actually, when people do something, whether it is a gymnastic or a magic show or delivering a lecture, or when your parents cook in your home, when you just means curious bystander, you find it very easy that it's okay, he is doing. But when you have to do, then you realize the means pain you need to take. So when I am solving problem, it may seem very easy to you, but when you will try to solve, you may not find them that easy. Anyway, let us go to next problem. Uh, Three phase 50 hertz star connected alternator with two-layer winding is running at 600 RPM. It has 12 turn per coil, 4 slot per phase, sorry, 4 slots per pole per phase, flux per pole is 0.035 Weber. Here also it is a sinusoidal distribution. Now we have to determine the phase and induced EMF. Here also you have to assume that turn and phase are series connected. Now first of all we have to find out, here number of pole is not mentioned, but 50 hertz is mentioned, and speed, like among these three, pole, speed and frequency, any two need to be mentioned to figure out the means remaining. So if it is we can write P is equal to this is the formula, ns is equal to 120 f by p, where sorry, it is p into f by 120 no, just a minute, that f is equal to n by p into 120, ns by p into 120. So from this we can write ns is equal to 120 f by p. So if it is 120 into f by p, then or p is equal to, from this you can write 120 into f by ns. So here f is given 50 hertz, ns is given 600, so your p is 10. Now the number of total slot, see here they have mentioned total slot per pole per phase, and that number is 10. Oh, sorry, 4. 4 slots per pole per phase. So how many poles we are having? 10. So how many phase we are having? 3. So 4 into 3 into 10. This is also abbreviated as SPP, slot per pole per phase. This is the number of phase, and this is the number of pole. Actually, I quite often make mistake in numerical calculation. Doesn't imply or means you do not have any obligation that as your teacher makes calculation mistake, you are also obliged to make calculation mistakes. You are free to correct it at your first attempt, but it is very unlikely. Whatever I have means my experiences, as well as whatever I have means how much I got the chance to study your performance in examination, or your means the question you threw to me. All these things make it very clear that you people are not observant. You use your quarter, means if your eyes means whatever information you could gather, you use your sense organ in such a poor manner that you could gather only 1/4 of that. So means be careful that you may make mistake in your first attempt. Why I am saying so? Because this time it may so happen that we will have our end semester, and in that case you will find it a bit anyway. Hope for the best and prepare for the worst. I can only hope, because I cannot help you much in your preparation. I can only hope that you prepare yourself for the worst situation. But do remember that what I was trying to tell, that this time there is a high chance that you have to sit for your end semester examination, and if your end semester examination takes place, then it will be means you can expect means this portion of your syllabus could occupy or hold a lion's share in your total question marks distribution. So be careful. So what is slot angle? Slot angle is, say, again 180 into number of pole by slot. So pole is 10 and slot is 120. So that leads us slot angle is equal to 15 degree. This is the always in EE. This is between adjacent electrical means slot angle, adjacent slot in electrical degree. Obviously, if you try to find out it in terms of mechanical degree, you will find it will give you somewhere 3 degree, right? So mechanical degree and electrical degree are not same. Now we have to calculate KB1. In many books they do not write KB1 or KP1, but it is my advice to you that please inculcate this habit of writing it in index, because otherwise what would happen, you will miss the order of harmonics, and later on we will study the problem where we need to calculate this pitch factor for different harmonics or breadth factor for different order of harmonics. So if you do not inculcate that habit, later on you will write KB for fundamental, KB for third order, KB for fifth order, and eventually you will get confused and ended up with the wrong answer. So that is not desirable. What is your SPP? That is your aim. So here it will be how much? Actually, if you observe minutely, it is only the governing factor is M. That gamma has a little control over it, because once you decide M, that is under your control, you are bound to have a particular gamma. Why? Because M gamma, that is the phase spread, here we are working with narrow spread, so M gamma will always be 60 degree. In case of widespread machine, M gamma will be 120 degree, but as this is a narrow spread machine, it is M gamma is equal to 60 degree. So what you will get here, okay, now unlike the previous problem, this one is not a full pitch coil, it is a corded coil, so we have to calculate the pole pitch also. So pole pitch is how much? Like 120, that is the slot, by 10, that is the pole, it is 12 slot per pole. Now what is your coil pitch is given? Let me write it. Coil pitch is equal to pole pitch, that is only for full pitch coil, and coil pitch not is equal to pole pitch, that is for short pitch or corded coil, right? Now here in this problem they have given coil pitch is equal to 10. Clearly it is short means coil, in other book it may be written coil is corded by two slot, or in other book it may be written that coil is corded by an angle of 2 into electrical angle, that is 2 into a slot angle, that is 15 degree, or we can write the same problem that coil span So any one of these means including the one that is mentioned in the question, any four means among these four, any means you can pick up any sentence and that makes same sense. That makes same sense. So don't get confused, right? Now here you have to calculate that like Kp. So Kp is what? Amount of chording in terms of electrical angle. We have already considered that chorded by 30°. So Kp will be cos of Kp1. Again I am mentioning that please write Kp1, otherwise you will not get it. So it will give you 0.966. So induced phase EMF will be how much? Again your favorite formula without knowing what this phi indicate, whether peak, whether average, whether RMS, but we are T20 player who are very fond of hitting this ball, even having zero control over the direction of ball. We just know we should hit it very hit it very hard. So that is what all the time that what occupies our brain. So without knowing phi, whenever we see phi, we just put what is the value of phi, what is the value of phi? It is 0.35. So let us be 0.35 into your, here it is in P. So number of turns per phase, that is how much? That is number of turns per phase is, I think somewhere we have calculated it. Okay, number of turns per phase we have not yet calculated, but you can see that it is 4 slot per pole per phase. So obviously you can understand that there will be 12 slot, no, 4 into, like here you can see that 12 turn coil. So slot, this will be 12 turn per coil. So in pH can be calculated as your total, your N is total slot is this is our coil, now what I was thinking that how could we modify it, like in this could be mentioned that 24 conductors per slot. So here it will be 24 conductors per slot, but in that case you need to include this, means number of conductors should be divided by 2 to get the total number of turns. So it will give you, if you put it, it will give you something 480. So 480 into your Kp1 is 0.966 into Kb1 is 0.958. If you do this, what you will get? You will get 3451 volt, and accordingly this you can write 1 to indicate its fundamental. Right? Well, so our third problem here we'll study a little bit different one. I have selected many almost similar problem, but they are not exactly same. Like here, if you consider all the problems, you will gather some knowledge, some insight when you will complete solution of solving one problem. But the idea behind selecting this problem is that you can grasp the total concept, and there should not be any like lacuna in your understanding. So that is why I will solve many problems. So here, let me quickly read the problem. A two-pole three-phase 50 hertz 2000 1300 volt synchronous machine has 42 slots. Each slot has two conductors in a double layer winding. The coil pitch is 17 slots. Each phase winding has two parallel paths. Calculate the flux per pole. Okay, in this regard, I would like to ask you one question, that we have full pitch or chorded pitch. Can we have extra pitch? Like suppose if my coil span should be 10 to achieve the angular span of 180 degree, can we have 12 coil so that the angular span become 216 between the two means terminal conductors? Is it possible? Think about it, right? So the coil pitch is 17 slots. Each phase winding has two parallel paths. Calculate the flux per pole required to generate a phase voltage of this much. Likewise, here few things we should note, that like all other three-phase machine, whenever voltage is specified without mentioning it is line or phase voltage, you have to consider it is a line voltage. Now, this two-pole three-phase 50 Hz synchronous machine, like here, it is not mentioned that whether the windings are like how we are going to connect the winding, but obviously we can consider it star or delta, that doesn't make much difference. Each slot has two conductors in a double layer winding. The coil pitch is 17 slots. So here each phase winding has two parallel paths. That is why I have selected this problem. Previously what you studied, if we go back, you will see that it was like turns per phase are series connected. Now here we are having two parallel paths, like instead of the previous case, here we are having parallel path. So how to solve this problem? Let us first find out that M is slot per pole per phase. So how much it should be? 42. What is your number of pole? 2 poles. So it is 7. Now what about slot angle? Now what about KB1? That is breadth factor. It is sine 7 into 8.57 degree by 7 by 2 into sine 8.57 by 2. So if you do this, you will get what? You will get, it will give you 0.956. Do remember one thing, although here we are using degree, but later on when we will consider means there is many coils, like M is very high, in that case gamma will become infinite small, and in that case you should use radian only, otherwise you will get an erroneous result. So coil pitch is 17 slot. Now pole pitch is 21 slots. Now short pitch by an angle. What is the amount of short pitching or chording here? So what is the amount of chording here? Chorded by an angle theta, that is how much? 21 minus 17 into 8.57 degree. So that would give you how much? That is 34.28 degree. Now here, what is your Kp? Kp will be, you know, this cos, this is it actually we denote it by rho, so cos rho by 2. So you will get it 0.956. Sorry, it's 0.952. Now all this doesn't make much difference. What will make much difference here is that the number of parallel path. So parallel path here, number of turns will be how much? 42 slots. Now 2 conductors per slot, and like that double layer winding, so 42 into 2 must be there. However, in the denominator, each phase winding has 2 parallel paths, so number of turn obviously will reduce. Like what I am trying to say, suppose if you have total number of conductors, you can figure out. Now if you connect them in parallel, then what will happen? Actually here we can consider another 2, like what I am trying to say. 42 is the number of slots. Let me write, then you will get it. Slot into number of layer into number of conductors in every layer, divided by 2 into number of phase So here it is 2, and number of conductors, like means what I am trying to say, if multiple conductors are there in the number of layer, here number of conductors in layer. So what I am trying to say, your slot is 42 into, here you are having 2 number of layer into 1 conductor in each layer, divided by 2 into, because 2 conductors are required to form a turn, 3 is the number of phase, then number of parallel path is 2. So you will get 7 number of turns are present in every phase. Now you can proceed, like we can proceed. It's like KB1, KP1, F, NPH into phi. Again, we do not know what phi this is, but we know it is phi. So EA is given 2300 by root 3. So you can figure out phi. That would be 0.94 Weber. Now, if we ask you to draw the winding diagram, what you will get? That is also an interesting question to ask. Like here, this is 42 slot, 2 layer, one conductor in each layer. Now, then two parallel paths. Coil pitch 17. So, how to proceed? Right? Can we draw it? So obviously, this drawing of this much slots will cause a hell lot of time, but I would like to hear from you that you can consider it as an assignment and try to draw it by yourself. And let us check. Let us give up our on our means hatred, animosity, whatever you are having for me, just for the sake of electrical machine. Just try to do it. How to realize this? You have time. You can draw the 42 slots. There is no harm. And even if you draw it, I am giving you best assurance that I will try my best to convey to your message to the means teachers or whoever is there, means to change the teacher. Unfortunately, the means load was already declared. Means there was a planning, and when I asked UCR, they took some time to confirm me the result that many students do not want me anymore. So, but I need means by the time I could convey it to them, that already it was decided that the other teachers are already occupied with other subjects. But anyway, I'll obviously try my best to settle this issue with you people. Now let us see that another problem. This is our next problem. This is our next problem. Here we will consider the case of widespread winding. Let me write for three-phase winding with coil span of 160 degree. We have to determine the distribution factor and distribution factor like for the one case when it is uniformly distributed, widespread coil having coil span of uniformly distributed to having a 9 slot per pole, 9 slots per pole, right? So in this problem, first see that this is a widespread case. So what is your phase spread in widespread spread case? That m gamma in case of narrow spread it is 60 degree, in case of widespread it is 120 degree, right? So it is 120 degree. Now here for the first case, uniformly distributed means uniformly distributed can also be read as, or its interpretation is like m tends to infinity, gamma tends to 0. This is what does uniformly distributed means. Now what is the formula for that? It is sine m gamma by 2, and here it is how many you can have here, like total angular spread is 120, so you can have here 120 by 2 into your, that is means like this one will result you pi by 3, so this will result you I need to calculate, yeah, something like 0.827. Okay, now what is the amount of cording? Cording is do note here I have used angle in radian, angle in radian. Now if this is your rho, so you can figure out what would be kp1, that will be cos 20 by 2 cos 10 degree, which will give you 0.9848. So you will have winding factor kw1 is equal to kb1 into, sorry, this one should be kb1, so you will get 144. Now in the next case, when you have 9 slots per pole, Kp remains same, but Kb1 need to be recalculated. So the recalculation will yield 9 slots per pole. So here, if it is 9 slot per pole, then obviously slot per pole per phase will be how much? Slot per pole is 9. Now this should be right. So this will give you, sorry, here it is, just a minute. Yeah, now it's correct. Actually, I am not considering two here, and then again you have to consider by 2. So I am not doing that. Instead of considering 120 degree by 2, I am considering already 60 degree. Now this will give us 0.8312. So Kp1 remains same. So you will get new Kw1, that is 0.8312 into, you will get 0.8186. Well, now you have got idea about uniformly distributed coil, and then also widespread in this problem, but still we are not sure what is that phi, that flux, what value we are taking, that RMS or whatever. Now let us consider a slightly theoretical problem. If uh, Q is the number of slots per pole, let us show, or means we have to show, or we have to prove that distribution, we have to prove that and pitch factor for the harmonics of order Q plus minus 1 is same as that of the fundamental harmonics, and if this cannot be reduced by your uh, distribution factor and pitch factor, then what mechanism do we need to means calibrate, or means not calibrate, rather attenuate these harmonics? That we need to know. So Q is the number of slot per pole, and we have to prove that distribution factor and pitch factor for this harmonics, the order of harmonics is given, that is 2Q plus minus 1. So if Q is equal to say 10, then it is either 19 or 21 harmonics, that we have to prove that it is, this will result the same one. Now here it is no way claiming that the original, or had you considered like normal coil, like having that concentrated full pitch coil, then the magnitude of fundamental harmonics is obviously 1000 times, even without any winding manipulation, is 1000 times, or means I'm saying 1000 times just to in a literally way, but it's quite stronger. The fundamental harmonic is quite stronger than that of your this harmonic of order 2Q plus minus 1, because generally Q is a large number. We use slots, and especially for large machine there is number of slots is also very high. So this 2Q plus minus 1 is a quite higher order harmonics, and it is very, means we know that from Fourier series expansion Gibbs phenomena that if we increase the higher order harmonic order, then obviously its magnitude is bound to get reduced by certain amount. So obviously, even if your winding factors cannot treat or cannot attenuate them, cannot filter them out, they are also, you will be okay with them. But our question is that, can we devise any other mechanism to means circumvent this problem, or to attenuate them also, these particular harmonics of this particular order? For all other harmonics we can see that it is not problematic for us, they will be attenuated by our by our this winding factor, but for them it is an issue. Now see, so our concerned order of harmonics n is equal to 2Q plus minus 1. So what about KB 2Q plus minus 1? That will be so one pole, electrically one pole always covered pi by 2 angle. So one pole covers, sorry, one pole covered pi angle. Yeah, actually this is our gamma. This one is M, like here we are using Q, but it can be used as M also. So it is gamma. For that particular order of harmonics, it is your slot angle is for fundamental is how much? Now for that order 2q plus minus 1, how many poles you will have? If fundamental is having like q, then for nth order harmonics, for same slot, q is the number of slot. Even if you consider the most highest order harmonics present in the scenario, then also it remains q. Q is a means physical thing. But if you increase the order of the harmonics, then what we studied from that chart, just a minute. Here you can see that if you increase the order of time harmonics, what you are having here, that this indicates the number of speed, means that speed, like the fundamental harmonic on, like if you consider, it will that for just 1 minute, yeah, that for nth order harmonic, the number of poles will be n pi, right? For nth order harmonic, number of poles will be n pi, and that is the major cause for your reduction of. Now here, if that is the cause, then for nth order harmonics it is n pi. Like for fundamental, if you traverse pi, then for nth order harmonics it is n pi. And what is your n? That is 2q plus minus 1. Now like in the problem it is given harmonics, and we are very happy we are having harmonics, we know formula, but just hold on a second and think that which one we are talking about, which harmonic this is. This is space harmonics, this is time harmonics, which harmonic we are talking about? This is the harmonics that is present in our flux. The flux is non-sinusoidal, and for that flux, non-sinusoidal flux, we are having nth component, that is 2q plus minus 1 at this moment. Now for this 2q plus minus 1, as we have studied, that when you have say for fundamental, if you have ns, you can write n1 s1, then for three phase you will have n3 s3 n2 s2 n1 s1. However, this individual span is pi in terms of electrical, but in terms of slot, what you will get when you traverse this much to get pi. Here I have shown concentrated. Had we considered means placement of q slot, then this q slot traversal will result you how much? For fundamental you will traverse pi, but see here when you are even in two slots, you can understand from two slots here to here, when we are reaching here, we are traversing pi in for fundamental, and for three phase how much means angle we have traversed, that is 3 pi. So obviously for nth it would become n pi, but mind this is the non-sinusoidal flux that we are assuming there is a harmonic component present in that flux that is of order 2q plus minus 1, and for we have to prove that for that flux of that order, our winding factor is same as the winding factor which we get for fundamental one. So I hope you got some idea what is this one. Now what you will have in the denominator will have that q correct. Now see what we are getting, like we will have, if we simplify that in the denominator q sine, this one also give us 2 pi now this one again we can write it like 2 pi q by 2 plus minus pi q by 2, right? Now here q sine this is pi by 2q. Now what we know that sine in our like just a minute. Well, here I have made a slightest mistake, like this part is gamma, but here this m, actually what we should get if we consider it's a narrow spread coil, then m gamma should be pi by 3. So here it should not be q by 2, rather it should be m by 2, such that this one is pi by 3 for our fundamental, and for the higher order harmonics basically it should be nmy, that is n pi by 3. So accordingly here also it is m, right? So sine m by 2, yeah, now it will take a shape. What shape it will take, that is you simplify, it will give you sine m pi plus minus m pi by 2q and m sine 2 pi plus minus pi by 2q. So this gives us if we write it like sine, it is how much? Sine a plus minus b is equal to we can write it like that formula we apply, we will get what? We will get sine m pi sine a plus minus cos m pi sine m pi by 2q. Now this will cancel out, right? And here you will have sine 2 pi cos pi by 2q plus cos 2 pi sine pi by 2q. So the first term here means this actually I have strike them out like they due to this they will always give 0. So we can drop the first term. So what you will get here is that sine m pi 2q m sine pi by 2q. So obvious things that we can observe here, that if we cos 2 pi is 1, that is fine, but that in the numerator we can have cos m pi. If m is an even odd number, then you are going to get, obviously the way this question has been framed, it is clear from that framing of that question, the way it has like m is a whole number. So if m is odd, obviously it will become, if it was like plus, then you will get minus, and if it was minus you will get plus, like it will be minus plus sine m pi by 2q, and this one will be m sine pi by 2q. So it is clear that we are having that same whatever we had, like even if it is odd or even, for even it will remain plus minus, but it is quite okay that even if there is a sign change, but it doesn't make any indication that it will attenuate, right? So we have seen that it remains same for the fundamental and for the mth harmonics it is remain same. Now what is required is that to check the what happened in case of the pitch factor. So in case of a pitch factor, what you will get that for your nth order harmonics it will become, when your n is 2q plus 1, so here this one, this we can write like now what is q? Q is the number of slots per pole. So here if you consider the span 2q, basically you are talking about traversing 2 pi, means 2q slots, 2q number of slots a traversal of 2 pi. So it could be simply written like this. And this further can be reduced like this. Again here in minus plus depends on what is the value of rho, but that doesn't make any change in the amount of attenuation offered by this particular factor. So this is here one thing we have reached a conclusion that this slot, so here you can see that this when we are talking about a slot that is 2q plus minus 1, or in other way you can say that the slot that is having an angle span 2 pi plus minus located at a position 2 pi plus minus pi by q, there you will have uh, the distribution factor kb and kp are same as the fundamental. What I am trying to say, kb1, that is for the fundamental, is same as kb 2q plus minus 1, and similarly for kp, the pitch factor, kp 2q plus minus 1. So here it is clear that this one is also giving us that it's a fundamental. Now if you can recall my third lecture on this, then I have discussed there detail in about tooth harmonics or slot harmonics. So what is the order of that slot harmonics? If you can recall, that slot harmonics order is exactly 2q plus minus 1. So the slot harmonics, how to minimize the slot harmonics? One way to minimize the slot harmonics is the skewing of the slot. So you need to skew the slot so that you can get means like this order, like that To minimize these harmonics, you need to skew the slots. If possible, I am trying to show you what is this skewing means. Here in this diagram, you can see that bars, the rotor bars, they are not straight. Rather, they are skewed, right? So this type of skewing is done to calibrate that means slot harmonics or teeth harmonics. So we can do this to minimize this 2q plus minus 1. Obviously, one thing I would like to remind you once again that undoubtedly that magnitude of these harmonics will be very very small. If we go by that, if we consider that, first of all, again let us recall quickly what are all these about. Like, we are doing this for a non-sinusoidal flux distribution in space. However, that non-sinusoidal flux distribution, if we consider concentrated full pitch winding, then concentrated full pitch winding is obliged to exactly mimic the flux distribution in space, right? Now, in order to make the EMF shape, induced EMF shape, more like a sinusoidal, what we do, we distribute the coil over the entire stator periphery instead of or means over the entire armature periphery instead of allowing them to concentrate within a few slots, and we use cording. But one thing we should not forget, that these non-sinusoidal space harmonics, so and will means express them in form of summation of different harmonics, we will see that one term, the fundamental, is the strongest one, and this one, that 2q plus minus 1, is quite a higher order harmonics, and you will find that it is very very weak. But why do we need to minimize it? Because if we do not take care of these harmonics, although its magnitude is very small, but due to its very high frequency value, it may interact with nearby communication line, and there may means cause serious like an objectionable amount of noise it can infuse in that communication channels. And especially when today we are dealing with power line communication and other communication, that means communication not only for your means telephonic conversation or some data connection, it is also for giving you the signal to your system, to your generator, to your motor, whoever is there. So if there is it started interacting with that means signal lines, it will become a problem. And that is why, in order to minimize that, what we do skewing of slot, what you can see here, right? Now let us start with another problem. Now let us write another problem, that an alternator has a uniformly distributed winding with full pitch coils. So we have to find out just a minute. sorry, let us slightly change the phrasing of this question, that an alternator has a 144 number of slots, a three-phase alternator has 144 number of slots with 10 conductors per slot. The coils are full pitch, number of pole is 12. Now flux per pole, again not knowing which flux it is talking about, we will try to fit it in our formula. Flux per pole is 0.094 Weber. Now we have to determine the phase and line EMFs. That is easy, you can do it. Then slot harmonics we have to find out, but that you can also do it. But what is extra in this problem, that what would be the phase voltage if the coils are connected to form balanced two-phase winding. So 144, 10 conductor per slot, pole pitch, full pitch, number of pole 12, flux per pole 0.095. So I think we have already done part of this. Now here T will be how much? Assuming single layer. So here this is 10 into 144 by total number of turns will be 240. Frequency you have to find out. As it is 600 RPM, so no 500 RPM, so it will be how much? Now what is required? This is 50 Hertz. We have to find out KB. So in order to find out, you need to know gamma, that is interslot angle. So what would be the interslot angle? You have 144 slots. So 144, total 144 slots are there, and there are 12 like 12 pole machine. Okay, so one thing you can do that instead of finding out gamma, you can find it out m. M is number of M is equal to what? Slot per pole per pitch. So that is how much? 144 divided by 12 into 3. So M is 4. Now what we know that if we assume narrow spread, then M gamma is 60 degree. So gamma becomes 15 degree. So that makes the calculation easier. So let us calculate KB 1. So we are doing it for fundamental. It is sine, and here it is 4 sine. So you will get it like 0.958. Now that since coil is full pitch, Kp1 is equal to 1, so your E will be how much? E phase will be 4.44, and that heavenly formula where we do not know what is phi into Kb1 into Kp1. So all the values are known to us, into F. So all the values are known to us, either we have it was given or we have calculated. So if we do it, what we'll get? We'll get 2041 volt, and EL will be root 3 times of that. So you will get it 3535 volt. Well, so now what about the slot harmonics? Slot harmonics will be how much? The order of the slot harmonics will be slots, we can say that slots per double pole pitch, that is 2Q, will be how much? 144 is the total slot by into 2 by 12, right? Or either you can take it in this way, or you can take it in pair manner, like 144 by 6. Either way you are going to get the same answer. You will get 24. So the two triple harmonics will be how much? Either 25 or 23. Already we have discussed that, and how to get rid of that we have figured it out. Like we need to be we need to skew the rotor bar, as I have shown in while solving the last problem. You can solve this one also. Now here one thing that is very important to note, why I have picked up this problem for discussion, that the second part of the problem, that phase voltage, if the coils are connected to form a balanced two-phase winding. So balanced two-phase winding, what would happen in case of balanced two-phase winding? Try to understand that in case of your balanced two-phase winding, you have to first calculate the number of turns per phase. So that will be, see, number of conductors remain same, so 10 into 144 divided by 2 into 2. So how much you will get? That will give you 360 turns. Now 12 slots per pole. So number of turns per pole will be how much? Just a minute. Now we need to calculate the slot per pole per phase. That is M. That will be how much? Total number of slot 144. Total number of pole 12. Total number of phase 2. So this will give us 6. Now what about your here? It is KB1. KB1 will be how much? KB1, previous KB1 we cannot use because that was for 3 phase. Now we had it for 2 phase. So for 2 phase, your coil span, only one type of span is possible, and that is your M gamma should result 90 degree. So here in the denominator it will be 6 into sorry. So this will result 0.903. So what about phase voltage? Phase voltage will be 4.44 into your that particular flux per pole 0.04 into number of turns per phase 360 into frequency 50 into your distribution factor 0.903 into pitch factor that remains same because we have considered full pitch coil. Now our trouble will become much more severe if we had to consider a coil that is corded. Like amount of cording what was for 3 phase, now when we will transfer it to 2 phase, what would happen to that? That is a big issue here. So that you will get the total value after doing all these things, you will get it will be like 2887 volt. Well, now it is interesting to note that we have found out the phase voltage. What about the line voltage for a two-phase system? Have you ever considered the case of line voltage for a two-phase system? Line voltage for a two-phase system can be found out we do not use it because in case of two phase, because only two phase exists, that line voltage, uh, we will get only one line voltage. And even if you try to calculate it in two different way, the line voltage whatever will be calculated by using a different method will just be 180 degree out of phase from your first one. What I am trying to say, suppose you have a two line voltage like this, then you can find out VAB in this way, like like obtaining VAB is equal to VA minus VB, and then finding out their resultant. So when you try to find out VBA, then you have to do this, and you will get this one. So you can see that these two are 180 degree out of phase, and that makes no sense. Obviously, you can claim that for balanced two-phase circuit, it is balanced three-phase circuit. The line voltages are equal in magnitude. Only thing is that they are like 120 degree phase apart, but that doesn't make much difference, because whenever there is an like unbalanced condition or means imbalancing arises, then you can find out that line voltages are also not the same as like phase voltages. So there will be this means any absurd change in phase voltage always get reflected in your line voltages until unless these changes are symmetrical in nature, like symmetrical or not symmetrical, better to say identical in nature. Like in case of third harmonics, what we see that third harmonics in case of three phase voltage affects it in such a way that they cancel out each other, and same thing will happen here also in case of this three phase or any other multi-phase machine, right? So now what we'll have here, have you ever considered what happens when we will consider the effect of third harmonics on a two-phase system? Obviously, when time phase traveling we are talking about, when the fundamental traverse 90 degree, the third harmonic second phase will traverse how much? 270 degree. So basically, for this you will have, if this is our third harmonics, then its counterpart will be 270 degree lagging somewhere here. So on the contrary to your balanced two-phase, three-phase case, that all the third harmonics are identical and unidirectional, here you will have a slightest problem that third harmonics are not unidirectional, rather third harmonics are maintaining that opposite phase sequence. Like third harmonic will become here that harmonics that is having opposite phase sequence of your main phase sequence, right? So obvious question that comes in your mind, then which order of harmonics may comply or not comply, rather it may behave like the third harmonics behave in case of a three-phase machine. You can easily find it out. Say fourth harmonics, if any fourth order harmonics exist, they will behave like third harmonics. All the fourth order harmonics will become like in same direction for two-phase system. Anyway, let us go to our next problem. That next problem we state it is like, let me write the problem. The problem with this, all these problem is that I have collected them from an old book, so I cannot share it here directly. The pages are scribbled and like it is difficult to share a snapshot. I think it should be millimeter, because having 28 centimeter is a huge length. We cannot afford that much. Acha, air gap diameter. Okay, okay. Yeah, it makes sense. Like what they are trying to say. Yeah, I'll explain this term. It's a very small machine indeed. Now they have given the field strength, like instead of writing fundamental third, I am writing B1 to indicate fundamental flux density 0.87 Tesla. B3 is equal to B5. Oh no, B3 is 0.24, P5 is 0.14 Tesla. We have to estimate the resultant phase and line current in no load condition, sorry, phase and line voltage and also there is another part of this question, like we have to find out the per phase reactance at 50 hertz is 10 ohm. So we have to calculate the circulating current for delta connection, right? We have to find out the circulating current for delta connection. Now see here, it is interesting to note that this one, that pole pitch is equal to pi d by p. So let us find out the pole pitch. That will be, let us ignore the ripple, otherwise it will become more complicated. Now here we have to calculate the flux per pole for three cases. First one is for fundamental, let it be phi 1 and will be calculated from this one. Where that phi 1 can be written like, let me tell you that B is the given is the maximum flux density. So we can write for fundamental B1, actually it should be like this, dl by p integration running from your bm1 d theta sin theta d theta. So what you will get here, like dl by p bm1, it will be like so 2 dl by p bm1. Now what about your, so I hope this now you can figure out what is this flux all about. Now phi 3 will be how much? dl by p bm 3 sine 3 theta d theta. So this will give us so that will again result in so from this formula one thing we can write. Similarly we can figure out phi 5, that will also become so for Rth harmonic flux we can write it is like where BMR is the maximum flux value, right? So if this is the case, now using this formula, let us calculate the value for phi 1, how much, that is 2 dl b1 by p will be 0.0187 Weber phi 3 phi 3 is equal to your 2 into, here in this problem is so insightful, you will learn a lot about system. Right. Now here it is given that slot M is equal to slot per pole per phase is equal to 4, right? Slot per pole per phase is equal to 4. Now what about your slot angle gamma? How to find out? We know that for narrow spread gamma is M gamma is 60 degree, so gamma will be 60 by 4, that is 15 degree. Now you have to calculate KB1. KB1 will be how much? Sine 30 degree by 4 sine 15 by 2 degree will be 0.958. Now KB3, for KB3 what is that? Sine 3 into 30 degree by 4 into sine 45 by 2 degree. So that will result in 0.6533. Then you are having KB5, that is sine 150 degree divided by 4 sine 75 degree by 2. So that will give you 0.2053. Now we know these formulas. Now what is your coil is short pitched by one slot. So what about cording? Rho is equal to gamma. So that is 15 degree. So you have to calculate KP1, KP3, KP5, now that KW1 will be KB1 into KP1, that will be 91 into 958. So if you do it, you will get 0.949. KW3 is equal to KB3 into KP3, 0.6533 into 0.9238, 0.6035. KW5 is equal to KB5 to KP5, so that will result 0.163. Well, so now if you try to write it, what we need to know for that, that is the number of turns per phase. That will be how much? We are having total number of slots is equal to 4 into 3 into 6, because 4 is M slots per pole per phase, so 3 is number of phase, so this becomes 12 is slot per pole and 6 is the number of pole, so this is 144, that is number of slots, total number of slots that you have. Now here you can see that uh, there are two layer winding. So obviously if it is two layer, then you will get it like two layer, just a minute, where it was. Two layer. So we are having two layer winding. Uh, okay, one information I have forgot to mention there. Actually, it is a referred problem. In another problem, they have mentioned that every slot contains 8 conductors. So 8 conductors are there in every slot. So therefore, the total slot into number of conductors, right? Now if you divide it by 2, then you will get number of turns. Then if you divide it by 3, then you will get number of turns per phase. So if you do all this, you will get something like 96. Yeah, 6 cancel out from numerator denominator, you will have 12 into 8, 96. Fine. Now this one we can write E phase 1 is equal to 4.44 F KW1 NPH into phi 1. So this gives us 4.44 into 50 into 0.949 to 96 into what was phi 1? 0.0187. So you will get 378.4 volt. That is quite natural. It's a small machine. You should not expect a high. Now for third harmonic phase component, we will have what? How should we modify the formula? Now see how this formula should do. We should modify this formula for third harmonic. This is, remember, this is we are calculating the MMF due to third space harmonics. So instead of like your third order space harmonics should complete 3 cycles. So in your fundamental space harmonic complete 1 cycles. So for a certain amount of angle traversal, if your coil uh, experience one complete oscillation of fundamental harmonics, then for same angular traversal, your coil will experience three complete oscillation of your third order space harmonics. So then EMF due to third order space harmonics, this formula instead of F should be modified by 3F into KW3 into N phase. However, what happened to the flux, like your uh, how this flux will be means modified? This flux will be phi 3. Now, interestingly, if you note that while in derivation, phi 3 was already attenuated by a factor of 1 by 3 due to occurrence of 3 times of pole in comparison with fundamental. Like here, if it was the 2dl b1, yes, this is the general formula 2dl bmr rp. So for 3, phi 3, 3 will already come in your numerator, sorry, in denominator. And see the beauty here in that when you are trying to use it in your EMF equation, here it becomes 3m. So basically we are going to get 4.44 into 3 into 50 into whatever you have calculated, that is 0.6035 into phi 3, that will be 0.00172. So that will give you how much? 66.40 volt. Similarly, we can calculate voltage for E phase 5. So that will be EPH5 is equal to, how to write, by same logical argument we can see that three phase 1 will be 4.44 into, it should be 5m, because when your coil is experience one complete variation of fundamental space harmonic cycle, then it must experience 5 complete cycle of your fifth order space harmonics. So 4.44 into 5f into kw5 into nph into phi 5. So that will result in this one is 0.163, pH remains same. So what is the value of in pH? It is 96 into, okay, last time I probably forgot to write 96 here. Yeah, here it should be, another term should be there, that is 96. In pH is 96, that remains same for all of them. So NPH 96 into that. So you will get something like 10.422 volt. So all these are now for star connected alternator, that your resultant EPH will be EPH 1 square plus EPH 3 square plus EPH 5 square. So that will result in 384.32 volts. Right. Now, in case of line, what you will get? Now further we know that this one is like this one will be 0 plus this one will be so that results is equal to 655.63. For delta connection, the next part for delta connection, the third harmonic EMF means that is the only EMF that is short circuited by delta. So in that case, E phase will be E line will be at current, third harmonic circulating current will be 3 E phase 3 divided by 3 into your reactance value is 10 for 50 Hz, but third harmonic space induces a EMF of frequency 150 Hz, so your reluctance will become 30 ohm. So that will result 3 into 66.4 by 90, that is 2.213 ampere. Okay. Now let us consider another problem. The field for a star connected three-phase machine is given by 100 sin theta plus 30 sine 3 theta plus 10 sine 5 theta. Just let me check whether it's recording or not. Yeah, it is recording. So where this theta is measured from interpolar axis. If the stator has 9 slots per pole and coils are full pitch, determine the waveform of the phase voltage in terms of Vm, that is the amplitude of the fundamental voltage, determine also the phase and line voltages. Oh God, RMS value. What would be the value of phase and line voltages become if the flux become sign distributed in space while keeping the total flux per pole constant. So total flux per pole, again here, after solving this problem we'll get a complete idea what is total flux per pole, right? So let us start. But before we start, let us just quickly means draw some inferences from the last problem that we have solved. If if you see these two equation of this one and this one, here it is f, here it is 3f. However, this phi, whatever you are having phi 3, so whatever you are having here phi 3, this is actually the flux per pole, and due to occurrence of 3 flux, it was already divided by, means if we go back to the calculation of these fluxes like phi r 2 dl bm r rp, so let us cut this one. Now let us paste it here. Now again here you can see that E1 is equal to E1 is equal to 4.44 into F into KW1 into phi into NPH, and E3 is equal to 4.44 into F into KW3 into phi 3 into NPH. Now in both the equation, let us put this value, like replacing phi 1 and phi 3 by their corresponding values. So what you will get here, let us write it at the first place and then write phi 1. Phi 1 will be 2dl by p b1r, sorry, bm1, and this one will become 2dl by 3p bm3. So if you take the ratio of these two, E1 by E3, you will be able to note that they basically become very simple thing, that is bm1 by bm3 into kw1 kw3. So if you can evaluate one of these, then the other one, especially for this type of form, means like problem where you know the flux density, right? This is for the flux density waveform is given. So this one will become very simple and extremely useful for you. Now generalizing, we can write E1 by ER is equal to BMR KWR. So with that, let us go to the next page. Now we can write, first of all, let us calculate the winding factors. Coils are full pitch fortunately, so there is no changes required. For fundamental, it is breadth factor is sine 60 by 2, 3 sine, like how I am getting 3, we have to calculate that same thing. M gamma is equal to 60 degree if we consider narrow spread winding. So here M is how much? Slot per pole per phase, that is already given. Slot per pole is 9, so 9 by 3 phase, that is 3. So M is 3, that implies gamma is equal to 20 degree. So if that is the case, then we can write KB1 sine 30 degree, 3 sine 10 degree. So that will give KB3, that is sine 90 degree by 3 sine 30 degree. So that will give you 0.667 KB3 sine 150 degree divided by 5 sine 30 degree. So 0.218. Now we will apply those formula that we have just discussed. So E3 will be how much of E1? E3 will be B3 by B1 KW3 KW1 into E1. So that will give you 0.3 into so that is 0.147 Vm. Now E5 you can figure out similarly. B5 by B1 KW5 KW1 into E1 is equal to 0.1 into 0.218 into how much? 0.96 remains same. Here again E1 is 0.707 Vm. Why E1? Because E1 is the RMS value. That when we did that calculation, we considered it in that way. So if Vm is the peak amplitude by fundamental waveform, then obviously this is the case. So we'll get it 0.16 Vm, sorry, 0.023, sorry, 0.16 Vm. Okay, now we have to figure out the voltage values. So E3 will be root 2, means rather V3M will be root 2 into 0.147 Vm, which is also Vm1. We will get 0.208 Vm, and while Vm1 is equal to Vm and V5M is equal to root 2 0.016 Vm is equal to 0.023 Vm, right? What about the wave shape of the voltage? The wave shape will be E phase is equal to root 2 E1 sine omega t plus E3 sine 3 omega t plus E5 sine 5 omega t. What about the means voltage when we are assuming that at t is equal to 0 omega t is equal to theta, so we are getting these values. Now if you want to find out the in terms of Vm, then you will get it like Vm sine omega t plus 0.208 Vm sine 3 omega t plus 0.023 Vm sine 5 omega t, right? So what about the RMS value? RMS value will be square plus 0.147 square plus 0.016 square into Vm square. So you will get this is equal to 0.722 Vm. I have copied the answer, final answer from book, so I am not sure about the correctness of this one. Rest of the steps I think I have done correctly. So, but it is desirable that you check the calculation by yourself. Now this will be root 3, again by same logic as it is star connected. Third harmonics cannot be present or contribute in the line voltages, they will cancel out each other. So will be root 3 into root under 0.707 square plus 0.016 square into Vm. So that gives us 1.225 Vm. Now why I have selected this problem, there are two reasons. One is about get to know about how to solve this type of problem, especially where flux density is given, how the ratio of two induced EMF can be expressed as an like here. Yes, this is very important relation, you may take a note of that. And also that what is flux per pole, what value it indicates. Now here see, when we the second part of the problem, in the second part they have said that what would be the value of phase and line voltages become if the flux becomes sign distributed in space while keeping the total flux per pole constant. So how with this non-sinusoidal flux distribution we are having some total flux per pole, and they are asking us that if that same amount of flux has to be sign distributed in the space, then what changes we would get in that resultant harmonic? Intuitively, we can understand that the changes that we can expect is that there will be no other higher order harmonics present in the EMF equation. So, due to absence of those harmonic, obviously their voltage contribution will also be absent. However, due to means obviously when you are trying to keep your flux per pole constant, obvious and want to make the waveform sign distributed, you are actually trying to strengthen the main field or fundamental flux, right? All these flux we are talking about space harmonics, not time harmonics, right? So why I have been several times talking about space and time, because this is something very important in rotating machine. Unlike transformer where you just need to consider only time harmonics, here space and time both matter, and you are the person, like we often call it, like trio of space, time and the person or the people. So you have to, means it is your responsibility to make sure you take care of the space as well as the time. Like if any minute change takes place in space, then it may alter the time waveform, because here the total things is based on the dynamically induced voltage, and the main part of dynamically induced voltage is that if you consider concentrated full pitch coil, then induced EMF will exactly mimic the waveform. Space variation of flux will be exactly replicated by your time variation of induced EMF. However, one thing you must understand that if you do certain manipulation, like here we have done is distributed winding. Had we taken a short pitch coil, then in addition to that KB, some KP will also come in the picture. However, we will see that that KP will also similarly means alter or modify. So eventually we could apply this formula irrespective whether Kp is equal to 1 or Kp is having some value or not. Right. Now, so how to find it? See here, it is like, first of all, if I ask you to find flux per pole, so let me draw a very rough sketch. Suppose this is your one pole and this is another pole. You are having, what is the angle, electrical angle? This angle pi radian electrical. Now, when here, generally what should we expect? We should expect a sinusoidal flux variation. How? Like we can expect here the flux to be maximum positive, say if we draw the flux waveform, we should get it like this. For sinusoidal case. And this one should be like let me just, and this one should be, so basically in your interpolar region you should get 0, and it is like this kind of waveform you will get. And when you go for a perfect surface development, you will get, however, when your this is not in sinusoidal, rather it is like, I'm just trying to give you a rough idea. Then obviously this will change change to that non-sinusoidal shape, whatever. But do remember, it must be half wave symmetric. We cannot means destroy this half wave symmetric property as long as we do not change the position of the. So these kind of things we can expect. Now, how to determine the flux per pole? So, if you have to find out the flux per pole, what you need to do is that you need to carry out the total flux. See, this is what? This is the flux density waveform. This is our space angle. So, if you integrate the flux density waveform with respect to space angle, what is expected? You will get that total flux under the pole. However, there is one problem, that you have to take care of like, means if you integrate this, you will get the total flux density under one curve. But you are actually interested to find out flux per pole, not flux density per pole. Or means, so what is your way out is that it is when you try to find out flux per pole, you need to multiply the area that is perpendicular to your flux density vector, right? So what is that area? That area is your dl by p is the amount of area. Like if you go for surface development, then you will see that any, like, don't consider the total means lateral surface area, rather try to understand as if we have placed a rectangle inside this, and that rectangle will face kind of, what to say, that this rectangle will face flux variation. So what you will get here, that you can write like flux per pole is d by l dl by p, integration running from 0 to pi 100 sine theta plus 30 sine 3 theta plus 10 sine 5 theta whole integration with respect to d theta. So why don't we apply that direct formula pi dl by p? We could apply if we had a sinusoidal distribution of flux, but as this one is not sinusoidal, so we can't apply. So basically, if you do this to find out the flux per pole, you will get plus 2. So like instead of carrying out this from 0 to pi, what I did is a very simple thing. I exploit that symmetry, quarter of symmetry, 0 to pi by 2, and this I take 2, so this will become simple. So if you do this, you will get so all the upper limit will give you 0, and you will be having, so total flux per pole when we will have a sinusoidal flux distribution, what we could get is in the form of sine distributed field will result as 112 sine theta, right? Now here if we see that 100 sine theta, it was responsible for production of an RMS voltage 0.707 Vm. Now this 100 sine theta, if you change it by 112 sine theta, you can expect 1.12 into 0.707 Vm. That is how much? 0.79 Vm. And as this only contains fundamental harmonics, no higher order harmonics, only fundamental, because your space wave is sinusoidal with this consideration, so your line voltage will become root 3 into 0.79 Vm, that will be 1.37 Vm. Okay. Okay, now let us take the another problem. A stator slot, uh, a stator slot no sorry, so many problems are there. each slot of the rotor of a three-phase 50 Hz synchronous machine contains 1000 ampere conductor. What is that? I will explain. That is why I have picked up this problem. There are three rotor slots per pole. Do remember, in synchronous machine, rotor actually responsible for production of pole. So this problem is very interesting in that regard. The angle between two successive rotor slot being 30 degree, the area and length of the air gap is 0.5 meter square and 2 millimeter respectively. Here we can consider that this 2 millimeter is the the outer periphery of this rotor and the area of inner periphery of the stator with certain degree of approximation. The number of turns of each phase winding is 100 turns. Just let me check for the recording now. 100 turns per phase. So, and the winding is narrow spread. Determine the RMS value of fundamental phase voltage. So what are the data given? The data given are like here rotor pitch is not given, we can consider rotor is full pitch. Now rotor ampere turn is given, sorry, ampere conductor, not ampere turn. What is the difference between ampere conductor and ampere turn? That, as we know, the difference between number of conductors and number of turns, the same difference exists here in ampere conductor and ampere turn. Now the interesting things is here is that rotor, whatever is described in this way, it we can it will not be a very, what can I say, weird guess or weird, oh god, weird approach to consider that the rotor is having distributed winding. If the rotor is having distributed winding, then what we have discussed, that we can always expect a wave shape like where it is. This kind of wave shape you can always expect because your rotor conductors are distributed. Now see that here, if after doing simplification, what we got, it's like this formula we are going to get for rth harmonics. Now we'll consider only fundamental, not the higher order harmonics. So if that is the case, then it will be reduced to 4 pi a this by q, and that q is here, it is your, what was q, just a minute, I just okay, q is the number of slot. Yeah, I remember q was the number of slot. So why it was needed to calculate the value of a, and from that what you get ultimately, it was like final formula will come in this form. Yes, this is what we want. However, here instead of giving us NP, it is given ZI, right? So if we divide ZI by 2, we'll get NP. Anyway, so here we can apply that formula. A, we are only considering the fundamental one. 4 pi A KB, what here? Strange. 4 pi KB1 KP1. Alright, and what about that A? The total A will be as I told you, unlike n p into I, it will be n z I by 2. So what is n into zi? Zi is given 1000 and n is 3. So 3 into 1000 by 2, that gives us 1500 ampere turn per pole. So if that is the case, then we can write, okay, calculate kp1. kp1 will be sine 60 degree by 2, sorry, sine, here what is the angle? uh, like it is given, rotor slots being 30 degree, like gamma r is the rotor slot, it is 30 degree and 3 slots per pole. So am is equal to 3, mr is equal to 3, so it should be like 3 by 30 by 2 into mr sine gamma r by 2. So mr is 3 and this one is 30 degree, so we will get it like 0.91. Now your A1 will be how much? We are considering full pitch, so 4 by pi into 1500 into 0.91, so 1738 ampere turn per pole. This is our fundamental MMM. Now we have to figure out the peak fundamental flux density. So peak fundamental flux density will be 738 divided by 2 into 10 to the power minus 3 air gap length into your mu 0, means this gives us H, the magnetic field intensity, and this is our mu naught. So that gives us 1.092 Weber per meter square. Now the fundamental flux per pole will be how much? Phi 1 2 by pi B1 into area of each pole. So area of each pole will be how much? See, it is given that area is 0.05. So therefore this one is 1.092, so it will be 8 whatever. So fundamental induced EMF will be E1 is equal to 4.44 into F into your fundamental in pH into your Kv1 into Kp1. Now here Kb1, Kp1, these are for stators, so you need to calculate them separately. So that like in pH over 2000. Now as it has mentioned narrow spread, so Kb1 will be sine 30 degree by 3 into sine the number of Slater slots they have not mentioned. So one thing I would like to clarify here, whenever you will see that there is nothing mentioned about the number of Slater slot, what you can do is that you can directly go for um, like approach that it's uh, oh, means you can directly go for the analytical means the formula for uniformly distributed field winding, right? So if you do that, we all know what we supposed to get, that it will be so this results us in pi by 3. Yeah, here also pi by 3. So okay. It is right. So you will get something like 0.955. Oh no. Sorry. Yes, now it's correct. So if you do that, you will get this. We are assuming full pitch coil. So Kp1 will be 1. So fundamental value of EMF will be 4.44 into 0.0348 into NPH, that is 100, into 50 is the frequency, into winding factor, that is 0.955. So eventually doing this you will get 737.8 volt. Now, as of now, we have discussed only cylindrical rotor machine. Now, we have to discuss the case of a salient pole machine. What is there? A flux density distribution is given, and also Let me write the complete problem. Flux density distribution is given. It's 2 pi by 3. This side is 2 pi. This side is 2 pi by 3. This is being half wave symmetrical, it is 1 by t. This is our space angle. This is our flux density. So now what is given that this is the flux density waveform, but unlike the previous cases, now we have to deal with a salient pole machine that is having projected pole. We have to draw the one complete cycle of the EMF generated in a single turn coil of coil span 150-degree electrical the coil moves with a velocity of 20 meter per second in peak flux density of 1 Tesla. The effective length is 0.8 meter. We have to calculate the RMS value. So one complete cycle of the generated RMS EMF we have to find out, and then we have to figure out oh, just a minute. So you have read that problem. Unfortunately, I have deleted it. So important information is that span was 150 degree and the coil moves with a velocity of 20 meter per second. Now we have to calculate the RMS value. As the rotor is salient pole, so you can see flux distribution with respect to space angle, that is concentrated, and it is like having a rectangular distribution. Now here one thing is clear, that had we considered a a cylindrical rotor like previous case, will have an uniform flux density distribution, or a kind of that trapezoidal type of flux density distribution. But here, due to this salient pole structure, poles are projected, so you can have only this. Now see that we have to draw the angle variation. It's interesting. What we can do is that, first of all, let us start. We are going to draw it with respect to omega t. What voltage levels we will get, that we will calculate, that is not an issue. But first, at this pi by 6 till this pi by 6, there will be no voltage. Let me try to draw the physical coil position. Like coil is having a span of 2, this is how much, 5 pi by 6, right? So when you are having your coil one end here, the other end is means whenever it is in this band of pi by 6, the other end will be where, like what I am trying to say, try to visualize it. I cannot help you to visualize totally, because it is difficult until unless you feel it. This span is 5 pi by 6, right? This span is 5 pi by 6. Now let me draw this is one side, this is another side. So as long as this one is here in this zone, the other end will be, say, in this zone, this is say x. So other end, this will be at x plus 5 pi by x, but that x plus 5 pi by x will surely be out of this 2 pi by 3. See how the voltage will get induced. Either this side or this side has to be under the effect of any of this flux, right? Has to link with any of this flux. However, when this region, say this x, when it is 0 to pi by 6, then one end of the coil is at 0 to pi by 6, another end of the coil was between 5 pi by 6 to pi. So both the range are already fall in no flux zone. However, when the flux your coil one end comes here, that is at pi by 3, then this region is pi by 6, sorry. Yeah, this region is also pi by 6. So when this coil comes at pi by 6. Then what happens? The other end, although the other end falls in no flux zone, but as this is in pi by 6, like here, this end comes here, right? So the coil position is like this. Although I am drawing a slanted figure, but you should try to understand that this is not slanted, this is a straight line. The coils end are like straight lines penetrating this board surface. So coil sides are actually perpendicular to this board surface. Now when one end of this is under your pole, like one end is here, then the other end will be here. Like if we call the starting end, this end say S and this end be T. So S is connected with flux, but T is not. But again, when we will shift it further pi by 6, so when we will reach here at pi by 3, then what we will see that both S and T will get associated with the flux. Means if I try to write it in region wise, then I can write, I hope this will make you understand better. When one end within 0 to pi by 6, other end at 5 pi by 6 to pi, and say let it be left side flux linkage 0, right side flux linkage 0. Now when it is in the zone pi by 6 to pi by 3, what is happening that, and the other end will be at what? You just add pi by 6 with 5 pi by 6, so pi, and then pi by 3 plus 5 pi by 6. So pi by 3 plus 5 pi by 6, it will be 11 pi by 6, right? So other end will be 11 pi by 6. You are having LS1. No, this side is not 11. What happened? Then pi by 3 plus pi by 6. This side is how much? Yeah. Sorry. It should be till 7 pi by 6. In this range, LS1 means LS linked, RS 0. In the next region, pi by 3 to your pi, what is this region? I am talking about this total region. So if we discard pi by 3, it remains minus this side will be in this region, and this one will be 2. What is this value? Just let me calculate. It is actually 5 pi by 6 minus pi by 3, that is pi pi by 2. So pi by 3 plus pi by 6 minus pi by 2 plus pi by 6. In this region, again I have missed a mistake. Like I want to tap that region till when you first this one, then it started like here. 2 pi by 3, so it will be 2 pi by 3 plus 5 pi by 6. So here I would like to make some correction. Here, like what is happening here, that pi by 3 to how much we have to consider, that 5 pi by 6, right? When one side is moving from 5 pi by 3 to this side will be, so then what you will have, left side, right side also 1. Then consider that mixed up, like when you are having your 5 by 3 to 5 pi by 6, then consider after 5 pi by 6 what you will have. You will have a region pi by 6 to like 5 pi by 6, let us consider first 5 pi by 6 to pi. When it is in this region, then what we will have, just a minute, 10 pi by 6, 10 pi by 6 to 10 pi by 6 to that 11 pi by 6. Right. In this region, what you can see, that in this region it is like LS0 RS1. Why? Because which region I am talking about? See, 5 pi by 6 to pi and 10 pi by 6 to 11 pi by 6. So 5 pi by 6 to pi is this region. Here it is your, I am talking about this region. So where your one side will be here, then the other side will be pi by 3 plus in that region. So obviously it will fall somewhere here, right? So again, when we will find ourselves means here means pi to 7 pi by 6, then we will see that like 11 pi by 6 to 2 pi, we will have LS0 RS0. So basically one if we take this total here basically try to understand one thing, that LS RS means the two end of the coil, but this whole thing, if you add with considering this gives us a positive direction of voltage, then just let me copy this somehow. Uh, so what we'll get from this, that if this is our, then for first half we can construct, that is from 0 to pi. 0 to this one is for first one, 0 to pi by 6. So 0 to pi by 6, your induced EMF is 0. Then pi by 6 to pi by 3, only one portion is there. So you will have this kind of wave shape till your pi by 3. Then after pi by 3, you are having twice, because both end comes under that, pi by 3 to your 2 pi by 3. Sorry, not this here. Pi by 6. Okay, then here this much is what was that angle? I forgot the range. Okay, now see here, pi by 3 to 5 pi by 6. Try to understand one thing, whatever this is for left hand side, right hand side voltage will just be with opposite polarity. Like you are having two batteries, one battery is seated at left arm and the other battery is seated at right arm, and whenever you are means moving, if LS is equal to 1, that means the one battery is giving you full voltage, another battery is giving you zero voltage. LS1 RS1 means both the batteries are giving you full voltage and their polarity are such and means adjusted that the total series voltage is means giving you sum of the two voltages. So here pi by 6 to how long we will go, that is here it will become pi by 3. So here we will get 5 pi by 6. No, sorry, pi by 6 to this range actually. I think I have made some mistake here. 6 to, yeah, this should be 2 pi by 3. Then after 2 pi by 3, obviously this will be 2 pi by 3 to, don't get confused, let me just tell you what I am trying to do here. That very simple thing, pi by 3 to 2 pi by 3. In this range you are having your one arm inside this, and the other arm that will getting uh, pi by 3 plus 5 pi by 6. Then here 2 pi by 3 plus 5 pi by 6. So let us check what is the value we are getting. Just let me just give me 1 minute to calculate the value. Pi by 3 plus 5 pi by 6. So it is like this side gives us 7 pi by 6. That's okay, and that should be the case. 7 pi by 6. Now this side should be how much? Same, 7 pi by 6 plus 2 pi by 3. So that is 11 pi by 6. Yes. So 2 pi by 3 to 5 pi by 6. Then here it is 11 pi by 6. And this side should be 2 pi by 3 plus 5 pi by 6. No, sorry. It is 9 pi by 6. Yeah. Now it make oh God. 2 pi by 3 plus 5 pi by 6. How much it is coming? Okay. Now 2 pi by 3 plus 5 pi by 6. Actually my calculator is not working. That is why I have to do calculation. Means okay. Then here 5 by 6 to 2 pi. Then here it is 10 pi by 6 to 11 pi by 6. Then right now it makes sense. So what combination I have written, just what I am trying to do, instead of doing this arbitrary kind of things, let me make it more simple. Like my intention is to break the whole interval in that, means whole 2 pi in an interval of pi by 6. All these are pi by 6. Then this one is pi by 6, 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 pi by 6, pi by 6, pi by 6. So here the idea is very simple. Like let me check how much we have considered. No, we need to make the interval of shorter span. It is consuming the whole space. There should be 12 such segment, 12 such interval. So here it is like pi by 6. Let me draw it. Give me a minute, then I will draw. This first pi by 6, then this is the second pi by 6, then here we will have that. Oh, sorry. Actually, problem is that the scale is also not drawn in diagram means according to that hierarchy. These two sides are pi by 6, fine. Now here we must have 4, right? 4 such interval. That uneven distribution of interval is obvious, but just let me draw the diagram quickly and then I'll get back to you. So here now I have drawn it correctly. The first one is pi by 6, the second one is pi by 3, third one is your pi by 2, then fourth one is your 2 pi by 3, then your like here it is 5 pi by 6, here it is pi, here it is 7 pi by 6, here it is 8 pi by 6 means 4 pi by 3, here it is 3 pi by 2, here it is like exactly that 2 pi by 3 plus pi, that is 5 pi by 3, then here it is 11 pi by 6, then 2 pi. Now we are done. Now what is my idea? Just let me make you clear again that since what is the motive between dividing this all these are of pi by 6, all these intervals. Why we have broken it in pi by 6 intervals? Because this pi by 6 we come from means we have decided or we have taken this pi by 6 because our call span is 5 pi by 6. Therefore what we can have is like if we add a full pitch coil, then we can readily draw the means voltage waveform diagram. Voltage waveform will exactly mimic the flux density waveform. But since coil span is 5 pi by 6, then what is needed, that first of all we have to calculate the angle of means I'm trying to give you a scientific approach, or means more an algorithmic approach that you can follow. Now break it in that interval. Now find out when one arm of your coil is in this interval, the left side or LS, the right side should exactly be 5 at an angle 5 pi by 6. So if that is the case, then obviously for the first interval what I have written 0 to pi by 6, and that then both are means associated with 0 flux. In the next interval pi by 6 to pi by 3, here it is pi to 7 pi by 6, then it is LS1 RS0, then pi by 3 to pi by 2. Or what we can do is that we can take this one, this pi by 3 to pi by 2, 2 pi by 3. So what we can see, or okay, let us take all the 8 segments, no need to hurry. So this pi, the other end can be found out by adding pi by 6 plus 5 pi by 6, that gives us pi to 7 pi by 6. Means what I'm trying to say, when we are at this interval, then also your ls is cutting 0 and rs is not, means linked with any flux linkage. Now let us take this segment pi by 3 to 5 pi by 6, and similarly you can get the other end by adding 5 pi by 6 with this. So if you add 5 pi by 6 with pi by 3, then you will get what? You will get 7 pi by 6. So here, if you consume 3 slots or 3 interval, let us consume 3 interval, not slot, 3 interval. So what are the ends? Pi by 2 to 5 pi by 6. So let us write it clearly. It is pi by 3 to 5 pi by 6. So merge it, 3 to 5 pi by 6, and this side to be 5 pi by 3. So in this region, LS, RS both is having 1, 1. Now in the next region, what we are having? We are having 5 pi by 6 to pi. In this region, what we can see that only RS is associated but not LS. So here in this zone, 5 pi by 6 to pi, pi by 6 to pi. Here you are getting 5 pi by 3 to 2 pi. You are having LS 0, RS 1. So let us quickly write their range. This is from the first range is 0 to pi by 6. Only this matters to us. Then for the second range, pi by 6 to pi by 3. The third range, it is pi by 3 to 5 pi by 6. The fourth range, it is 5 pi by 6 to pi. Actually, this only gives the first half or first lobe of our EMF, induced EMF. Why? Because two coils are connected in series, and we have considered that they are so connected that their polarities are additive in nature. So means the resultant voltage that you are going to get across them is the sum of these two voltages induced across this coil. So we can draw it, but before that I would like to copy this one. construct our waveform. So here we got the range as well as the arm which is having voltages. So let us first draw for 0 to pi. So 0 to pi, what we can see that 0 to pi by 6 there is no voltage. So it will be like no voltage. Then pi by 6 to pi by 3, that will be one-sided voltage. Then pi by 3 to pi by 6, both sided voltage. Then again at 5 pi by 6 to pi, one-sided voltage. So this is the waveform for our first half, and we know that due to the placement, symmetrical placement of our poles, the second half will is obliged to maintain half wave symmetry. So like the first half started at pi by 6, second half should started at 7 pi by 6. So if you still have confusion that how to construct second half, just let me show you that in case of constructing second half, you have to consider that your first term will be moving in this zone and the second term will be here. Like for the first pi to pi by 6, when your this one is at pi to pi by 6, then your first term at pi to pi by 6, the second term should be at, or sorry, pi to 7 pi by 6. The second term should be at which position? The second term should be at 11 pi by 6 to 2 pi. No, sorry. This should be 11 pi by 6. Yeah. Okay. So the second term is 11 pi by 6 to 2 pi. So we can write at this region pi to 7 pi by 6. You can see there is no flux, but the other one that is also having 0 flux. So you can write that LS, RS both 0, 0. Now consider 7 pi by 6 to your 4 pi by 3. In this region, your left side is under this pole and it is linked, but the right side, you can find out the right side, that will be 2 pi minus 2 pi to how much? 4 pi by 3 plus 5 pi by 6. So if you do this, you will get 13 pi by 6. But out of that 13 pi by 6, if you drop this means 13 pi by 6 minus 2 pi. If you do, you will find out this range, like it makes a complete rotation and the right side reaches here in this region. Now here it is your right side and your left side is here. Well, so right side 0 flux, left side negative flux. So this region minus 1, 0. Then similarly pi by 3 means here it will be how much? 4 pi by 3 to just double it, that will be 5 pi by 3. Like sorry, it will be 4 pi by 3 to how much? It is 11 pi by 6. 4 pi by 3 to your 11 pi by 6. In this region, the other end will be where? 4 pi by 3, 4 pi by 3 plus 5 pi by 6. So that will give you how much? Yes, 13 pi by 6, very good. That is pi by 6, true. Then 11 pi by 6. So this will give us 16 pi by 6, means 8 pi by 3. Now from 8 pi by 3 you need to subtract 2 pi. So you will be having 2 pi by 3. So this side will be pi by 6 to 2 pi by 3. So here, like when your left arm will be in this zone, like 4 pi by 3 to 11 pi by 6. Right arm is in this zone. Right. So right arm is this in this zone. So both of them will have negative voltage. So you will get what? Minus 1, minus 1. So I hope you got it. So you will get exactly now we need to figure out these voltages. It is 2V. If this is 2V and this is V, then we need to figure out this V and 2V. That we can do. It is not a very big deal. Now here you can find it out. You can find it out like the voltage is given, so it will be applying that formula, E is equal to BLV. So we know B is 1 Tesla, so it will be 1 into L is 0.8 into V is 20. So this is 16 volt, that means this one is 16 volt and this side is 32. Similarly here it is minus 16 and this is minus 32. So RMS value we need to find out. RMS value of singleton coil will be how much? Since it is having a half wave symmetry, one part is sufficient. Width of this side is pi by 2. You can figure it out because this 32 volt segment contains 3 intervals. Individual intervals are was a span of pi by 6, so 3 of pi by 6 will give you pi by 2. So basically we are doing that averaging and then whole this is up. So if you do this then you will get 4.44 volt, right? So I hope you got certain idea that how EMF gets induced in a three-phase system, a Salient pole system. Now let us take another problem, like if the same flux density is given and unlike the previous problem some different information are being served, like if we have this flux density waveform variation with respect to space angle, so let us go to next page. So what is written there, it's simple thing that unlike the previous one, now total turns is given. Previous one was single turn coil 360, then phase spread equal to 60 degree, then pole pitch equal to 0.6 m, stator length equal to 0.8 m, coil span 180 degree, we have to calculate the RMS value of the fundamental waveform. So it is like a combination of previous two problems. Only thing is that here you have to extract some information from this graph. So So what we can extract here, that Bm is 1 Tesla. As mentioned in the problem, Bm, this one is 1 Tesla. So from that we need to figure out that what would be the value of, as it is asked that fundamental, so what would be B1? So B1 will be 4 pi Bm cos rho by 2. So this one will be how much? That will be 4 pi Bm is 1 Tesla into cos pi by 6. So that will result in 1.10266 Tesla. Okay, fine. So pole pitch, that is pi d by p is equal to 0.6 meter. Actually our goal is to find out the flux per pole. So how can we do that? We can write phi 1 is equal to that p 2 by p b1 dl. We know this formula. So this gives us 2p d1l. Here it is that pole pitch means dia. We can write the dia d is equal to, as it is not given, p into 0.6 by pi. So p into 0.6 by pi. So this results as 2 pi into 1.10266 Tesla into your L is 0.8 into 0.6. So phi 1, that is flux under pole, that is the total flux actually. 95 bar here. So this much flux we have got from this calculation. Now find out the kV1. kV1 you can easily figure out, that is as it is mentioned uniform like whenever, as I told you, that whenever they do not mention slot, then you consider it is uniformly distributed. So sine 60 degree by 2 or sine pi by 6 divided by pi by 6. So you will get it like 3 by pi, whatever value you will get, 0.955. It has mentioned Kp is equal to 1 since it is a full pitch coil. So what you will have here, it is E phase 1 is equal to 4.44 into F into KW1 into B1 into NPH. So NPH will be how much? Total number of turns is 360. Since you have three phase winding, so it should divided by 3, so you will get 120. This will become 0.955. This is 1.10, and this one is 360 by 3, that is 120. So if you do this, you will get a certain number one. No, sorry, it is 0.336, 0.337 you can take into 120. So how much you will get? You will get 8567 point, sorry, 76.7 volt, right? So you get certain idea about how to deal with salient pole machine. Now we'll consider problem from armature reaction, right? Now switch to our armature reaction problem. So here let me write the question first, that two pole you people accuse me for recording long videos, this that. I know I am one of the worst teacher that you have ever had in your life, but one thing I can ensure that I could, I'm not, means I do not want to make comment on others and would like to refrain myself from making any loose comments, but I can ensure that at least from my case, I could reduce the burden by not showing or discussing solution. But then you will also have a very shallow understanding on that subject. Anyway, so our two pole 50 hertz 2.5 MVA 6.6 kV three phase connected turbo generator has the armature winding distributed in 60 slots with 4 conductors per slot. Now the armature coil has a span of 5/6 of pole pitch. The rotor has 8 slots per pole. Each slot contains 5000 ampere conductor, then and the slot pitch is like at angular gap between adjacent rotor slot. We have to determine the fundamental component of rotor mmf per pole and armature mmf. This is very important at full load. So let us begin. What should we should do here? Like first of all, let us calculate the rotor mmf. It's easier. We know that it is A1 4 pi. This is total kW1 ampere turn per pole. So this A, do remember one thing here, the rotor is carrying direct current, right? So this A is that kW, you know, so we'll get what A is equal to, the peak value should be how much? That number of slot per pole into your number of ampere conductor by 2, that is 8 into 5000 by 2, 20,000 ampere turn per pole. Now this 20,000, however here coil pitch are different. Here we can assume that coil pitch is, this is the full pitch coil, that KB1 is equal to 1. Now KB1 need to be calculated, that is how much? How should we proceed for fundamental? It is sine 8 slot into 14 by 2 and divided by 8 into sine 14 by 2. 14 is the adjacent rotor slot angle. So it will give you 0.85, though you can calculate rotor mm that we have already no, this will give us A1 is equal to 4 by pi into your 20,000 into 0.85, that is 21650 ampere turn per pole. Now the challenge is to calculate the armature mmf. So armature mmf, if you can recall, it was unlike this one, it is an mmf that is varying with space. Let us go back to that equation. Right now I am writing at 101 page. So this was at 70 pages. So that formula of armature mmf is this harmonic mmf. So armature mmf formula is this 0.9 into your number of, like for a three-phase machine it is 0.9 into 60, like whatever n you will have number of turns per pole, then this formula we should apply, right? So now what you will get here, just let me check whether it's recording or not. So it's recording. Let me write that formula for armature mmf, that is, let it be AR1 and armature mmf B on 1, that is how much, 0.9 into m into m is the number of phase into np is the number of turns per pole per phase. So that into I into kW1. So this gives us 0.9 into 3 into, here number of turns per pole was given, like number of turns per pole will be that 60 slot with 4 conductors per slot. So 60 slot with 4 conductor per slot will be so 60 into 4 divided by your 2 is that it will convert it in turn, then divide it by 2, that is number of pole, then into 3, that is number of phase, then into I, we have to find out I, kW1 we have to find out. So how to find out I? That as it has mentioned that armature MMA per pole at full load. So full load current we need to find out, that is I is equal to, given it is 2.5 into 10 to the power 6 divided by root 3 into so full load current is 218.17 ampere. Since it is star, so this is our IL is equal to I phase is equal to IL in case of star. Now KW1 is equal to KB1 into KP1. This is for stator I am doing, or armature. So KB1 will be how much? 60 degree narrow spread, and there is like sixty slots are there. So phase spread 60 degree. So we can find out that slot per pole per phase. That is 10. Then what about slot angle? So this will be how much? Sine 30 degree divided by 10 sine 6 degree means by 2, so sine 3 degree. So this will give us 0.955, and armature coil is not full pitch, so again we need to calculate P1 also, that is 5 by 6 span means chorded by an angle of pi by 6 or cos 30 degree. So by 2, so that will be 0.966. So this gives us this one is equal to that armature, its formula we put it here, 218.7 into this one 0.955 into 0.966. So this will result as 10895 ampere turn per pole. So that's all. That is for your armature. Now another question that is interesting we can discuss in this regard: the flux density, of flux density in the air gap of a synchronous machine is represented by B is equal to B1 sin theta plus B3 sin 3 theta minus alpha 3 plus B5 sin 5 theta minus alpha 5. This is from the book of Langston, where theta is an angle in electrical degree from neutral or interpolar axis. Determine the values of alpha 3 and alpha 5 for which the flux per pole will be independent of harmonics. Basically, they are trying to mention that cancel out them. So, under the above condition, if the flux per pole is 0.11 Weber, like with this condition, if the oh god, we have come again reached the end of this page. So this is the problem. Now flux per pole will be independent of harmonics. Now in addition, they have mentioned that under the above condition, flux per pole is 0.11 Weber, B2 is equal to 0.3 B1, and B3 is equal to, sorry, B3 is equal to 0.3 B1 and B5 is equal to 0.1 B1. So what is the RMS voltage induced at the frequency of 50 Hz? So how to find out? First of all, let us apply our old technique, the flux per pole, the pole pitch. Flux due to rth harmonic under a pole pitch will be how much? Now d by 2, unlike the other case, it should be 2 by p d theta L. So if we do this, we will get something like minus br by r dlp cos r pi minus alpha r minus cos r alpha r. So it is clear that we can make the above value 0 if we ensure that phi minus alpha r is equal to alpha r is equal to pi by 2. So if we want the flux to be independent, then obviously that alpha 3 and alpha 5 must be pi by 2. So what does that indicate? Like if you want the flux to be, then your means those flux should be present only at the interpolar region. Then only we cannot get any change due to their effect. Right? Now the RMS value of fundamental conductor per conductor is how much? For one conductor it is just half of 4.44. So it should be 2.22 into 0.11 into 50. So this is our 12.21 volt. Now in that same conductor, if you want to calculate the harmonic voltage, then it should be 2.22 phi r RF, and we can use that same formula that ER by E1 is equal to your like B1 by BR by B1 here. Yeah, BR by B1. So this BR by B1 will result in this flux. Yeah, so E5, E3 by E1 will be how much? As given, B3 and B1 is 0.3, so E3 by E1 will be 0.3 into, so you can find out if E1 is 12.121, so E3 will be 12.21 into 0.3, that is 3.66. Similarly, E5 by E1, that is 0.1, so you will get E5 is equal to 1.22 volt. E will be 1 square plus 3.66 square plus 1.22 square. So that will result in total 12.8 volt. Okay. So you got some idea. So let me discuss a problem from GET. So without copying it completely, what is important I'm writing here. Alternator is owned with a 60 degrees phase spread, means phase spread is M gamma, so that is 60 degree, it is mentioned. Now armature winding and develop, this alternator develops a kVA of 300 kVA. Now if the armature is reconnected utilizing all the coils for a single phase operation with a phase spread of 180 degree, then what would happen to the kVA? That is the question. Nothing is given, so you can assume that if nothing is given, then obviously you have the right to assume that it is uniformly distributed. So in case of uniform distribution, you know that for three-phase case, your KB, let us write KB1 3 to indicate it is for three-phase. It will be how much? Sine 30 degree divided by pi by 6. So that gives us 0.955, and for your KB11 it will be sine 90 divided by pi by 2. So that will give you some value 2 by pi. Let me calculate how much is 2 by pi. So 2 by pi will be 0.636. Now armature conductor remains same, so current capability will remain same. So basically KVA rating will be what? It will be just just the ratio of these two distribution factor, we can find it out. So kVA 3 by kVA 1 will be what? E by kVA 1 will be why the number of turns won't make any difference, because when you will consider three phase, then basically you will divide the available turns in three phases, right? So what approximation we are doing here, we are considering that even if you connect all the three phase turns in series and form a single phase winding, then also it retains the same current carrying capability. Practically, current carrying capability should be reduced by a certain extent, but we are considering for sake of calculation that the current capability remains same. So current conducting capability remains same. Now obviously whatever voltage you will get here will be your F into N phase into whatever. Now N phase is, for single phase, N phase is 3 times of your 3 phase turn. What I am trying to say, that problem is that whenever I try to say something, I reach at the end of the page. So V1 will be how much? N, that is 3 N phase, if N phase is for 3 phase, into F into kW1 into 4.44. And for V3, like this is for V single phase, this is for V3 phase. So what you will get? N phase into F into kW1, sorry, here you will have to take kW11, here it is kW13, kW13 4.44. Now see, when you will try to find out kVA for 3 phase, it is 3 V3 phase into I3 phase, and for single phase it is V single phase into I single phase. We are assuming I3 phase is equal to I single phase. However, this I3 phase should be some at least 10-20% greater than I single phase, because I single phase is being carried by an winding that is having 3 times turns of your 3 phase winding. So obviously it should affect the current carrying capability, but we are considering it same. Then if you take the ratio, ultimately it boils down the ratio between the two winding factor, and therefore it yields that it is 0.636 into 300, so that will give you 200 kVA. Done. The rest of the gate problems you can do in similar manner. Another problem, it is interesting, that it has written that, what is written there, that a 4-pole 3-phase 3-phase double layer winding is housed in 36 slot with M gamma is equal to 60 degree. Now coil span is 7 short pitch. We have to find out the number of slots in which top and bottom layers belong to a different phase. So to figure out top and bottom layer belongs to different phase. And now see, coil span is 7 slot and your this is coil span is 7. I just it is a typo is there, it is 7 slot pitch. So if that is the case, then what is your number of slot per pole? So 36 slots is a huge number of slots. In order to understand that, what we can do is that we can deal with means 18 slot 2 layer winding. Let me quickly draw 18 slot 2 layer. 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Alright. Now see here. Here what we can write that let us divide it in 9 slots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 12, 13, 14, 15, 16, 17, 18. So this is one pole side. Now coil span is corded by 7. So that means what you are having here, if A phase is denoted by red, then if you place 1, then instead of placing it at 10, that is 1 plus 9, you are placing it at 8. Now see that as it is 8, so all the coils will occupy 6, means like if you consider 18 is 360 degree, then 18 360 means slot angle in electrical is 30 degree. Slot angle in electrical is 20 degree. That means 60 degree phase split. One slot has to occupy, means one phase conductors will occupy 3 phases. So red, right. Now how you will get it here? Red. Now then if it is B, so 7 plus 7, 14, 15, 16,
done. Then C. So the 3. C should be placed at similarly 13 plus 7. So this is one set. Now another set. Let us start placing there. The rate should be at lower here. At 10, 11, 12. So then it should be at 17, 18 and 19, that is 1. Then you take yellow and it's blue, so that will be at here. And similarly 16 plus 7, that is 23, 23 minus 18, 5, accordingly 6 and 7. Now then remaining should be filled up by C phase. In the question they have asked that
How many slots you will have with different number of different coil at top and bottom layer. So for 18 you can see that how many coils you will have in the top and bottom layer. If you count, you will find that in each pole pitch you are actually having out of 3 coils, 2 are means different color. So if you just extend it, then you can find it out that out of 36 coils, 24 will be of different color. The simple formula is just obtain this 9 minus 7 is equal to 2. So if this is 2, then if for 3 it is 2, then for 36 slots it will be 24. That way you can do it. It is a simple formula. Also, that's all. And that is the last video of our syllabus.